Hello there, and welcome to the Sleepy Science Channel. Tonight, we'll take a gentle journey back through the mists of time to a land that once looked nothing like the one we know today. A world of towering forests, steaming swamps, and creatures so extraordinary that they still capture the human imagination millions of years after their last footsteps faded. This is the lost world of the dinosaurs, a world that existed long before humanity, when the Earth was younger, wilder, and constantly reshaping itself beneath vast and alien skies. These magnificent animals were more than just monsters of teeth and claws. They came in every size, shape, and color one could imagine. Some were no larger than a cat, flitting like shadows between the ferns, while others were titans that could dwarf the tallest buildings. There were gentle giants that grazed on treetops, fearsome hunters that stalked ancient plains, and delicate, feathered beings that glided through the canopy in shimmering displays of color. For over 160 million years, they ruled our planet, reigning over landscapes that changed from lush jungles to arid deserts, from icy poles to volcanic islands. And though they are long gone, their traces are still with us, in the bones we uncover, in the feathers trapped within amber, in the faint impressions of footprints left in mud that hardened into stone, and even in the birds that fill our skies today, living echoes of that ancient dynasty. So, as you settle in, take a deep breath, find a comfortable place, and allow yourself to drift with the rhythm of deep time as we explore the story of the dinosaurs, not as distant fossils, but as living, breathing wonders that once shared our Earth. The word dinosaur itself is a clue to how mysterious they seemed when humans first discovered their bones. It comes from the Greek words dainos, meaning terrible, and sauros, meaning lizard. But in truth, dinosaurs were never lizards. When early scientists in the 19th century uncovered gigantic bones buried in the rock, they assumed these belonged to monstrous versions of modern reptiles. It wasn't until more discoveries came to light that they began to realize how wrong that picture was. Dinosaurs stood upright, their legs held beneath their bodies like pillars, allowing them to walk and run with grace and power. Their hips and lungs worked differently from those of any lizard, and their bones grew quickly, more like those of warm-blooded animals. In fact, they were closer to birds than to reptiles. The name, terrible lizard, may have stuck, but the creatures it describes were far stranger, more dynamic, and far more diverse than anyone could have imagined. It is nearly impossible for the human mind to truly grasp how long dinosaurs dominated the Earth. Our own species, Homo sapiens, has existed for barely a few 100,000 years, and recorded history covers just a few thousand more. But dinosaurs flourished for over 160 million years, an expanse of time so enormous that entire continents drifted apart while they lived and died upon them. Mountains rose and eroded, oceans formed and vanished, climates swung from sweltering heat to freezing cold, and through it all, dinosaurs adapted. They survived mass extinctions, shifting habitats, and the endless turning of the planet's geological clock. Some evolved to thrive in the wet forests of the tropics, while others learned to endure long, dark winters near the poles. They weren't doomed or primitive, they were resilient and intelligent survivors. Compared to their reign, humanity's time upon the Earth is but a fleeting moment. For centuries, dinosaurs were imagined as scaly, cold-blooded beasts. But over the past few decades, discoveries have completely transformed that image. Many dinosaurs, perhaps most of them, were covered in feathers. Some wore simple fuzzy coats, while others had elaborate plumage used for warmth, camouflage, or display. Bright colors, iridescent sheens, and intricate patterns likely filled prehistoric landscapes with bursts of color, as males flaunted their feathers in mating displays or flared them in threats. This revelation brings dinosaurs to life in a whole new way, not as gray, lumbering beasts, but as vibrant, dynamic animals, filled with movement and grace. Their feathers link them directly to modern birds, the last surviving branch of their ancient family tree. When you watch a sparrow flit between branches, or hear the call of an eagle, you are hearing echoes of a world tens of millions of years gone. The world they lived in was equally breathtaking. During the Mesozoic era, the continents were joined together into a single massive landmass called Pangaea. Over millions of years, this supercontinent began to split apart, drifting slowly into the shapes we recognize today. As the land masses moved, climates changed, ecosystems transformed, and dinosaurs adapted again and again. Lush fern forests became windswept deserts, coral seas dried into vast salt plains. Volcanic eruptions darkened skies, meteor impacts reshaped continents, and still the dinosaurs endured, evolving to fit each new world. Their story is one of persistence, of life continually finding a way amid chaos. And then, one day, their long reign came to an end. About 66 million years ago, a vast asteroid struck the Earth near what is now Mexico's Yucatan Peninsula, releasing energy greater than billions of atomic bombs. The skies darkened with ash and dust, sunlight dimmed, plants withered, and the food chains collapsed. In the blink of geological time, 3/4 of all species vanished. Yet even in destruction, the story of life continued. Some small, feathered dinosaurs, the ancestors of modern birds, survived. They took to the skies, carrying within them the legacy of an age that had ended in fire. Every songbird, every hawk and pigeon, every hummingbird that hovers today is a living reminder that the dinosaurs never truly died. They simply transformed. So as you close your eyes and imagine that ancient world, see not just bones and fossils, but living, breathing animals. Picture the young sauropod taking its first steps beneath the shade of towering trees, the mother velociraptor guarding her nest, the herds of herbivores moving across golden plains beneath volcanic sunsets, and above them all, the small, feathered ones gliding between branches, chirping softly in a language lost to time. For millions upon millions of years, this was their world, full of color, sound, struggle, and beauty. The earth belonged to them, and they shaped it in ways we still feel today. Even our own existence is touched by theirs, for without the mass extinction that ended their age, mammals might never have risen to take their place. The next time you see a bird take flight, or hear its song drift across a quiet morning, think of the deep connection that binds us to those ancient beings. Life is a continuum, stretching unbroken from the dinosaurs to us. They are part of our past, just as we are part of their future. So tonight, as you rest, let your mind wander across those ancient landscapes, through forests of giant ferns and plains of cycads, across the shores of vanished seas where dinosaurs once left their tracks in the mud. Imagine the heavy rhythm of their footsteps, the rustle of feathers in the breeze, the low calls echoing in the humid air. Feel the immensity of time itself, patient, endless, and full of wonder. The world has changed beyond recognition, yet the spirit of those ancient creatures still lingers in every wing beat and every fossil that sleeps beneath the earth. And perhaps, in some quiet corner of the night, if you listen closely, you can almost hear the echoes of their world, the gentle, distant heartbeat of the dinosaurs that once ruled the earth. Over the last few decades, remarkable discoveries from China and far beyond have completely reshaped our understanding of dinosaurs, revealing a world far more colorful and dynamic than anyone could have imagined. Many species, especially the small, agile theropods, were covered not in scales but in feathers, sometimes soft, downy tufts and sometimes elaborate plumes that would rival the brilliance of modern birds. These feathers may have served many purposes: warmth in cooler climates, flamboyant displays of color to attract mates, or even the first experimental attempts at gliding in flight. Picture, for a moment, a velociraptor, not as the scaly, snarling beast of old movies, but as a sleek, bird-like predator, draped in fine plumage, its feathers shimmering as it darted silently through the prehistoric undergrowth. Fossils from places like Liaoning in China have preserved these details with astonishing clarity, showing the delicate impressions of feathers spread like halos around ancient bones. Some dinosaurs even bore crowns or ridges of quills along their backs or heads, transforming them into living works of art, their silhouettes adorned with dramatic plumage. These discoveries have changed everything we thought we knew. Dinosaurs were not simply cold, reptilian beasts but vibrant, active creatures, closer to birds than to lizards, their bodies alive with color and texture, their world a riot of movement, sound, and light. Feathers, after all, are more than just tools for flight or insulation. They are canvases of evolution's creativity. In the microscopic structures of fossilized feathers, tiny pigment-containing organelles called melanosomes. Scientists have uncovered traces of the colors these ancient animals once displayed. Some species had matte black feathers, others a deep, earthy red, and still others shimmered with iridescent hues that caught the sunlight like a prism. Imagine a small, crow-sized dinosaur perched on a branch 120 million years ago, its feathers glinting with flashes of emerald, violet, and gold as it flicks its tail or spreads its wings in a prehistoric dance. These displays might have helped it attract mates, intimidate rivals, or simply dazzle its forest home with color. What once was thought to be a dull gray world of beasts is now understood as a lush, vibrant landscape filled with hues and songs, a place alive with spectacle and vitality. Every time we watch a modern bird strut or sing, we are witnessing a living echo of these feathered dinosaurs that once ruled Earth's skies and forests. Among the most famous of all was the mighty Tyrannosaurus rex, a name that still sends a shiver through human imagination. Few creatures inspire awe quite like this colossal predator, whose very existence speaks of nature's power and perfection. Its massive jaws were designed for one thing: raw, crushing strength. Research suggests that the bite force of a fully grown T. rex could reach an almost unimaginable 12,000 pounds, easily the strongest of any land animal in history. That's powerful enough to crush bone clean through, turning the skeleton of its prey into splintered fragments with a single devastating bite. Its teeth were not thin, blade-like daggers, but thick, serrated tools shaped like bananas, perfectly built for gripping, tearing, and pulverizing. Once the jaws of a T. rex clamped down, there was no escape. Muscle, armor, and bone all yielded beneath its incredible strength. Yet despite its brutal weaponry, T. rex was no mindless brute. Fossil evidence suggests it may have been a cunning hunter, capable of bursts of surprising speed, perhaps even hunting cooperatively or scavenging when opportunity knocked. Its forward-facing eyes gave it depth perception, its senses were razor-sharp, and its brain was more sophisticated than once believed. It was a perfect balance of intelligence and power, a predator so efficient that its legacy has outlived it by millions of years. The image of this king of dinosaurs, roaring across the plains of Cretaceous North America, is the very emblem of dominance in the natural world. But not all dinosaurs relied on intelligence or ferocity to thrive. Consider the Stegosaurus, an herbivore that lived long before T. rex ever appeared. With its line of tall, bony plates rising along its back and its tail tipped with fearsome spikes, the Stegosaurus looked like something out of a myth, a creature forged of armor and grace. Yet despite its formidable appearance, this dinosaur had one of the smallest brains relative to body size of any animal that has ever lived. An adult Stegosaurus, weighing several tons, carried a brain scarcely larger than a walnut. For decades, paleontologists puzzled over this, wondering how such a massive creature could function with such a small control center. Some early scientists even speculated that it might have possessed a second brain, near its hips to help manage its enormous body. Modern research has dismissed that theory, showing instead that the Stegosaurus didn't need much brain power. Its slow, plant-eating lifestyle required little strategy, only the instinct to feed, move, and defend itself. With a body fortified by armor and a tail that could deliver lethal blows, it didn't need wit to survive. Its success reminds us that nature has many ways to triumph, sometimes brains, sometimes brawn, and sometimes simply the quiet persistence of adaptation. If Stegosaurus was the armored guardian of the Jurassic, the sauropods were its gentle giants, creatures so vast they stretched the imagination. Dinosaurs like Diplodocus, Brachiosaurus, and Patagodontan grew to lengths exceeding 100 feet from nose to tail, longer than 3 school buses parked end to end. Standing beside one would have been like gazing up at a living skyscraper, its neck rising 30 feet into the air to pluck leaves from the highest treetops. Its tail, long and flexible, swept behind it like a living whip, balancing the colossal weight of its body. These immense creatures were the largest land animals ever to walk the earth, yet their bones were marvels of engineering, light and filled with air sacs, much like the skeletons of birds. This design reduced their weight without sacrificing strength, allowing them to carry bodies that might otherwise have been impossible. With hearts the size of cars and lungs that drew in vast quantities of air, they moved slowly but steadily across prehistoric plains, grazing on ferns and conifers under the blazing Jurassic sun. How these giants supported such immense mass is still a subject of scientific wonder, but their existence showed the world of dinosaurs was one of extraordinary diversity, brilliance, and adaptation, filled with creatures that were far more complex, colorful, and intelligent than we ever imagined. These magnificent animals, who roamed Earth for over 160 million years, evolved in astonishing ways to conquer every environment, from lush forests to arid deserts, from swamps to plains, and they did so with anatomy, behavior, and ingenuity that continue to fascinate scientists today. Among the most striking revelations of modern paleontology is the realization that many dinosaurs, especially smaller theropods, were not the scaly monsters of old textbooks, but rather feathered, vibrant beings that bridged the gap between reptile and bird. In China and beyond, fossils have revealed delicate impressions of feathers still surrounding bones like halos frozen in time. Some species had simple tufts for warmth, while others boasted elaborate plumage that rivaled modern birds, shining with iridescent hues to attract mates, intimidate rivals, or camouflage in their surroundings. Imagine a velociraptor, not as a green, scaly predator, but as a sleek, bird-like hunter, darting through the undergrowth, its feathers glinting in the sunlight as it moved with precise agility. Some of these ancient feathers shimmered with microscopic structures called melanosomes, which revealed that certain dinosaurs might have been black, deep red, or even glossy like hummingbirds, glowing with metallic greens and purples. The prehistoric world, once thought to be a dull gray expanse of giants, was in reality a living kaleidoscope of color and motion, a vibrant theater where feathers flashed, scales glistened, and survival was as much about spectacle as strength. The mighty Tyrannosaurus rex, perhaps the most iconic of all dinosaurs, remains the ultimate emblem of raw power. Its bite, calculated to exert a crushing force of up to 12,000 pounds, could pulverize bone and muscle in a single snap, leaving nothing but shattered remains. Its massive, banana-shaped teeth were not delicate slicing tools but serrated daggers, made for gripping and tearing through even the toughest hides. Yet T-Rex was not a mindless brute. It was a cunning predator and, at times, an opportunistic scavenger capable of bursts of speed, strategy, and ambush tactics. Its vision was acute, its sense of smell extraordinary, and its brain far more advanced than once believed. On the opposite end of the intelligence spectrum stood the Stegosaurus, that gentle, plated herbivore with a brain scarcely larger than a walnut. Despite its mental simplicity, the Stegosaurus thrived, its back lined with sail-like plates for thermoregulation or display, and its tail tipped with 4 long, deadly spikes known as a thagomizer, which it could swing like a living mace. Fossil evidence even shows broken and healed spikes, proof that these weapons were not merely ornamental. They were used in defense, turning this slow herbivore into a surprisingly dangerous adversary. Meanwhile, the colossal sauropods, such as Diplodocus and Argentinosaurus, reached lengths of over 100 feet, longer than 3 school buses placed end to end, and weighed as much as 80 tons. Their long necks allowed them to graze from the tallest trees without moving their enormous bodies, while their tails stretched behind them like counterweights of muscle and bone. To sustain such mass, their bones were marvels of engineering, light and filled with air sacs that reduced weight without losing strength, a structure strikingly similar to the hollow bones of birds. This adaptation made them efficient giants, able to roam great distances in search of food while keeping their massive frames balanced and stable. Despite their immense size, they were gentle herbivores, feeding on the vegetation that blanketed prehistoric Earth, shaping entire ecosystems through their constant grazing. Some dinosaurs took dental evolution to an extreme. The hadrosaurs, or duck-billed dinosaurs, possessed intricate, dental batteries, rows upon rows of hundreds, even thousands, of tightly packed teeth that constantly replaced themselves. These complex systems turned their mouths into living mills, grinding and shearing fibrous plants with efficiency unmatched by any reptile before or since. Their teeth wore down, but new ones always emerged to take their place, ensuring a lifetime of effective feeding. This constant renewal of teeth wasn't unique to hadrosaurs. Predators like Rex also grew new teeth throughout their lives, replacing worn or broken ones to keep their deadly smiles sharp. In this, they share a trait with modern crocodiles, another surviving link to their ancient cousins. Among the most recognizable of dinosaurs was the Triceratops, a three-horned behemoth whose skull alone could measure over 8 feet long. Its brow horns stretched more than 3 feet each, and fossilized remains show scratches, fractures, and healed wounds, evidence of fierce battles, whether against predators like T. Rex or among males competing for mates and dominance. These confrontations would have been awe-inspiring displays of power, 2 armored titans locking horns, dust swirling as muscles strained. Yet, Triceratops was more than a warrior. Its wide frill likely played roles in courtship and communication, displaying colors or patterns that signaled health and readiness to mate. The combination of beauty and brutality made it one of nature's most elegant fortresses. If Triceratops was a fortress, Ankylosaurus was a tank. This squat, heavily armored dinosaur was sheathed in thick, fused plates, forming a nearly impenetrable barrier. Its armor was so resilient that even the bone-crushing jaws of T. Rex might have struggled to penetrate it. Some ankylosaurs bore massive tail clubs, solid balls of bone capable of swinging with bone-breaking force. A single strike could cripple a predator, turning the hunter into the hunted. Others had sharp spikes or ridges that added extra deterrence. These slow-moving creatures were built not for flight or speed but for endurance, survival, and defense. Their spiked tails and armored hides were nature's answer to the escalating arms race between predator and prey, showing that evolution's creativity was as much about protection as aggression. Dinosaurs didn't all rely on brute strength or size. Some, like the velociraptor, thrived through agility, intelligence, and teamwork. Contrary to Hollywood depictions, real velociraptors were not towering monsters but small, feathered predators roughly the size of a turkey. Their deadly elegance lay in their speed, coordination, and the curved, sickle-shaped claw on each foot that could slice into flesh with surgical precision. Fossils even capture moments of combat, such as one velociraptor locked in a deadly struggle with a protoceratops, both preserved mid-battle for millions of years. Evidence suggests raptors may have hunted in coordinated packs, communicating and strategizing like modern wolves. If true, these were among the earliest examples of cooperative hunting in the animal kingdom, a chilling display of intellect and instinct intertwined. Beyond their teeth and claws, dinosaurs were also engineers of breath and bone. Many species, particularly theropods and sauropods, had hollow bones filled with air sacs that connected to their lungs. This adaptation made their skeletons lightweight yet strong, and it allowed air to flow through their bodies in a one-way system, providing a constant stream of oxygen. This efficient respiratory system, found today in birds, helped dinosaurs maintain high energy levels and active lifestyles. This finding also ties into one of paleontology's great revelations. Dinosaurs were not cold-blooded reptiles sluggishly basking in the sun. Instead, many were warm-blooded, with internal heat regulation that allowed them to be agile hunters and long-distance travelers. Their metabolisms were closer to those of birds and mammals, supporting the view that they were active, dynamic, and alive in ways far removed from the lumbering monsters of old imagination. This leads us to one of the most profound truths in science. Dinosaurs never truly went extinct. While most large species perished during the mass extinction at the end of the Cretaceous, one lineage survived: the birds. Every pigeon, sparrow, eagle, and hummingbird alive today is a living dinosaur, carrying the genetic legacy of their theropod ancestors. Their feathers, hollow bones, brooding behavior, and wishbones all trace back to prehistoric origins. When you watch a bird take flight or hear its song, you are witnessing the distant echo of creatures that once dominated the earth. The discovery of Archaeopteryx, a fossil found in Germany in the 19th century, provided the missing link between dinosaurs and birds. This remarkable animal had teeth, claws, and a long tail like a reptile, yet feathers and wings like a bird. It was the first clear evidence that flight evolved gradually, through gliding and short bursts of powered motion, before achieving the effortless flight we see today. Its fossilized feathers, perfectly preserved, reveal both strength and beauty, an evolutionary masterpiece bridging two worlds. Ultimately, dinosaurs were far more than ancient curiosities. They were innovators of biology, masters of adaptation who filled every ecological niche imaginable. From the smallest, fleet-footed hunters to the longest-necked giants, from spiked defenders to airborne pioneers, their story is not one of failure but of success on a grand scale. Even in extinction, their legacy endures, in the songs of birds, the structure of bones, the colors of feathers, and the dreams of every child who imagines a world where giants still walk. The Age of Dinosaurs was not a static, gray prelude to mammals. It was a dynamic, radiant era of endless invention. And though their time has passed, their spirit remains in every beating wing and every whisper of wind that carries the echo of their ancient, thunderous footsteps. Meanwhile, another group of creatures ruled the upper world entirely, the pterosaurs. Though not technically dinosaurs, they shared the same era and ecosystems. These winged reptiles were the first vertebrates to achieve powered flight, their wingspans ranging from just a few inches to an astonishing 30 feet. They filled the Mesozoic skies with motion, their shadows flickering across the land and sea below. Some pterosaurs skimmed fish from the waves, their slender jaws slicing through water with pinpoint precision. Others soared like modern albatrosses, gliding for hours above open oceans, while some prowled the ground on long limbs, stabbing at prey with dagger-like beaks. For more than 150 million years, pterosaurs and dinosaurs coexisted, creating a dynamic world of land and airbound hunters, each thriving in its own element. The Mesozoic skies were never empty, they pulsed with the beat of countless wings. Back on the ground, the story of dinosaur life continued in cycles of birth, survival, and death. When it came to reproduction, some dinosaurs demonstrated astonishing productivity. Certain species laid clutches of dozens of eggs at once, creating massive nesting colonies that resembled avian hatcheries on a gigantic scale. Fossilized nesting grounds show rows upon rows of eggs spread across wide plains, suggesting that entire herds returned year after year to the same places, just as sea turtles do today. The landscape would have been alive with activity, mothers laying eggs, hatchlings struggling free from their shells, and predators circling nearby for an easy meal. For these dinosaurs, survival was a numbers game. Producing many eggs increased the odds that at least a few would live long enough to carry on the species. And not all hatchlings were left to fend for themselves. Some species, such as hadrosaurs, stayed in their nests for weeks or even months after hatching, relying on the protection and care of their parents. Fossil evidence of juveniles with underdeveloped limbs shows that they couldn't have wandered far, indicating parental guardianship. Imagine a nest brimming with downy hatchlings, chirping softly as a massive mother shaded them with her body or brought morsels of food. These scenes of tender care reveal that dinosaurs weren't the cold, indifferent reptiles we once imagined. They were attentive, social, and capable of nurturing their young. The link between dinosaurs and modern birds isn't just physical. It's emotional, rooted in behavior that transcends time. Further proof of dinosaur social behavior lies not in bones, but in their footprints. Fossilized trackways stretching across ancient mudflats reveal herds traveling together, massive sauropods walking in unison, hadrosaurs moving side by side, each step preserved for eternity. These tracks tell stories that bones never could, of migration, companionship, and protection. Large adults often surrounded smaller ones, forming living fortresses against predators. In some places, predator tracks appear alongside those of prey, offering a frozen glimpse of pursuit and survival. The rhythms of movement, some slow and deliberate, others fast and chaotic, paint a vivid picture of life long gone. Dinosaurs were not solitary wanderers. They were members of tightly knit groups, moving in coordination across landscapes shaped by ancient winds and shifting seasons. And for some species, those landscapes were vast. Evidence suggests that certain dinosaurs migrated across hundreds of miles, driven by changing weather, food availability, or breeding cycles. Just as modern wildebeests or caribou traverse entire continents, massive herds of herbivores like hadrosaurs may have crossed plains and mountain passes, following vegetation as it bloomed and withered. Such journeys required endurance, cooperation, and memory, traits that further illustrate the intelligence and adaptability of these creatures. Imagine the thunderous rhythm of thousands of feet moving together, the dust rising beneath them as they crossed rivers and valleys, guided by instinct and sky. Through all of this, breathing innovations, aquatic prowess, experiments in flight, communal living, and parental care, dinosaurs reveal themselves as far more complex and dynamic than mere prehistoric monsters. They were explorers of every element: air, land, and water. Their bodies were masterpieces of design, their behaviors rich and diverse. Even in their extinction, they left behind a story written in stone, a story of life's persistence, creativity, and boundless curiosity. The earth they once ruled was not a barren wasteland of roaring beasts, but a vibrant, interconnected world teeming with movement and meaning. Dinosaurs didn't just dominate their age, they defined it, laying the foundation for the world that would come after, a world that still echoes with their legacy in every bird's song, every fossilized footprint, and every whisper of wind that moves through time itself. Dinosaurs were among the most adaptable and wide-ranging creatures ever to walk the earth, thriving from the lush equator to the frozen poles and conquering every environment in between. Evidence from isotope studies of fossilized teeth reveals that many species migrated seasonally, traveling hundreds of miles in search of food, water, or better climates. These isotopic signatures, which match distant water sources, confirm that dinosaurs were not static inhabitants of small territories but dynamic wanderers who followed the rhythms of the planet. Imagine endless lines of dinosaurs moving across vast floodplains, towering herbivores leading their young, predators pacing in the shadows, and pterosaurs gliding above under vast prehistoric skies. These migrations likely mirrored those of modern animals such as caribou or wildebeest, driven by instinct to chase abundance through changing seasons. As they crossed rivers, forests, and plains, their journeys would have reshaped entire ecosystems, spreading seeds, fertilizing the land, and keeping the balance of life in motion. Their ability to traverse continents was made easier by the geography of their age. During the Mesozoic era, Earth's land masses were arranged differently, often joined together in massive supercontinents like Pangaea and later Gondwana and Laurasia. These continental configurations allowed dinosaurs to spread freely across connected territories. Fossils discovered on every continent, from North America and Asia to Africa, Europe, and even Antarctica, revealed just how globally successful they were. Dinosaurs were true planetary citizens, occupying deserts, forests, coasts, and mountain valleys. Their bones in Antarctica, found among traces of fossilized trees and leaves, tell a story of a continent that was once green and vibrant, far from the frozen desert it is today. During the Age of Dinosaurs, Antarctica was a land of forests, rivers, and seasonal light, a world of abundance and extremes. Imagine dense conifer forests stretching across rolling hills, giant sauropods wandering between trunks that reached high into endless summer daylight, and months of near darkness during winter when the sun barely rose. Dinosaurs in these polar regions adapted to the cycles of light and shadow, perhaps growing feathers or insulating layers to endure long winters, storing energy when food grew scarce, and relying on warmth from group behavior. These adaptations paint a picture of life flourishing even in the coldest corners of Earth, proving that dinosaurs were not simply creatures of the tropics but hardy survivors of every climate imaginable. Just as the southernmost continent once hosted forests full of dinosaurs, the far north, near the Arctic Circle, was home to its own prehistoric populations. Fossils discovered in Alaska and other Arctic regions show that hadrosaurs, ceratopsians, and even small theropods roamed lands where snow covered the ground and the sun vanished for months. These Arctic dinosaurs endured freezing temperatures and long, dark winters with astonishing resilience. Many may have been warm-blooded, their metabolisms keeping them active while other reptiles would have been immobilized by cold. Some species had large eyes, adapted for seeing in dim light, while others likely lived in herds for safety and warmth. Fossil trackways suggest that these dinosaurs did not simply migrate south when winter arrived, they stayed year-round, toughing out the darkness and cold. Picture herds of hadrosaurs trudging through snow-laden forests, steam rising from their bodies as predators stalked the edges of their paths. Hatchlings may have been born in the endless daylight of polar summers, growing strong enough to survive the months of twilight that followed. This ability to live and even flourish at the edges of the habitable world demonstrates the extraordinary versatility of the dinosaur lineage. In these polar regions, winter brought months of unbroken night, yet life persisted. Dinosaurs with keen night vision may have hunted or foraged under the dim light of the stars and auroras, their senses tuned to a world of perpetual dusk. Some scientists propose that they huddled together for warmth, much like penguins do today, forming living fortresses against the cold. Such behaviors would have required complex social structures and cooperation within herds. The very fact that they endured months of darkness shows that dinosaurs were not sluggish, cold-blooded reptiles but active, warm-blooded organisms capable of maintaining internal heat. Their ability to adapt to extreme light cycles, cold temperatures, and scarce food resources made them among the most resilient creatures of their time, a testament to evolution's ingenuity. Among these adaptable species were the hadrosaurs, often called duck-billed dinosaurs, for their broad, flattened snouts. Their appearance might seem almost comical at first glance, but these were some of the most advanced and successful herbivores in prehistory. Their jaws contained hundreds of interlocking teeth arranged in grinding batteries, capable of processing tough plant matter with incredible efficiency. With their beak-like mouths, they could strip leaves, chew stems, and crush fibrous vegetation far more effectively than most animals of their era. Some species grew over 30 feet long, traveling in immense herds that roamed across continents much like modern grazing mammals. Fossils of hadrosaurs are among the most abundant of all dinosaur remains, found from North America to Asia, indicating their dominance and adaptability in a wide variety of habitats. But hadrosaurs were more than efficient eaters. They were also among the most visually and acoustically remarkable creatures to ever live. Many species possessed elaborate crests or hollow skull extensions that transformed their appearance into something almost alien. These structures weren't mere ornaments. They were instruments of communication. Inside some crests were complex networks of air passages connected to the nasal cavity, allowing the dinosaurs to produce deep, resonant sounds. Parasaurolophus, one of the most famous hadrosaurs, had a long curved crest stretching up to 6 feet from its skull, forming a natural horn. Air passing through it could have produced haunting, low-frequency calls that echoed across prehistoric plains. Scientists using computer models have recreated the possible sounds of these calls. Deep, vibrating tones similar to foghorns, capable of traveling long distances. Imagine standing on a Mesozoic floodplain as the sun sets, when the air begins to hum with the low, booming notes of a Parasaurolophus calling to its herd. One call becomes 2, then 10, until the valley trembles with a chorus of living horns, a prehistoric symphony resonating through the evening mist. These calls likely had multiple purposes: communication, mating displays, or warnings of predators. A herd spread over miles could stay connected through vibrations that traveled not just through the air but through the ground itself. Fossilized ear bones reveal that hadrosaurs could detect infrasonic frequencies, sounds too low for human ears to hear. These deep rumbles carried across great distances, allowing entire groups to move or respond in unison. Dinosaurs communicating through sound vibrations adds a new dimension to how we understand their world, not silent and still, but alive with the murmur of deep tones and rhythmic calls. The Parasaurolophus crest was not only a tool of sound but possibly a display of beauty and power. Its size and shape could have indicated health, age, or social rank, and some scientists believe the crest may have been brightly colored, adding a visual element to its role in communication. In life, a herd of Parasaurolophus would have been an awe-inspiring sight. Tall, elegant, their colorful crests glowing in the golden light of ancient sunsets, each one capable of producing music that rolled like thunder through the landscape. The evolution of such features demonstrates the intricate balance between form and function that defined the dinosaur world. These animals were not just brute survivors. They were thinkers, builders, singers, and caretakers. The more we study them, the more their world comes alive, not as a static tableau of fossils, but as a vibrant, ever-moving ecosystem filled with light, sound, and rhythm. They marched across continents, endured the polar dark, called to each other with voices that could shake the air, and adapted to nearly every climate Earth offered. From the snow-covered forests of the north to the sun-drenched plains of the south, they lived as part of a connected biosphere that thrived for more than 160 million years. Dinosaurs remind us that life is endlessly creative, that evolution's imagination knows no boundaries. They were more than bones and teeth. They were innovators, travelers, parents, and singers of ancient Earth. In their footprints lies the story of motion and endurance. In their calls, the first music of the land. And in their survival, the lesson that life, no matter how harsh the world becomes, will always find a way to adapt, endure, and fill even the coldest corners of the planet with warmth and wonder. Revealed that dinosaurs lived in a world far more colorful and vibrant than the one we once imagined. Microscopic structures called melanosomes preserved in fossilized feathers have allowed scientists to reconstruct hues that range from deep reds and brilliant blues to metallic iridescence like that seen in hummingbirds. Tiny, pigment-bearing cells show patterns and shades that hint at dazzling displays once common across the prehistoric landscape. It's now believed that many small theropods, especially those closely related to birds, were clothed in feathers with vivid colors used to attract mates, warn rivals, or blend into their environments. Picture a forest filled not with drab reptiles, but with a kaleidoscope of plumage, creatures glinting in sunlight, scales and feathers gleaming with subtle gradients, and brilliant frills pulsing with life and motion. These revelations transform our image of dinosaurs from hulking, earth-toned beasts into dynamic, living organisms that inhabited ecosystems as rich and visually complex as those of today. Color was not a rarity, it was a language. It spoke of dominance, courtship, and camouflage, of individuals flashing displays in moments of challenge or retreating into patterned shadows to avoid detection. The idea that dinosaurs might have been dull now seems almost absurd, because every new fossil with pigment traces adds evidence that their world was alive with color, pattern, and meaning. Their feathers and skin were canvases of evolution's creativity, tools for communication as much as protection. Beyond their colors, dinosaurs were part of ecosystems that pulsed with balance and struggle. The Mesozoic landscape was teeming with life, ferns unfurling beneath towering conifers, cycads carpeting open plains, and rivers carving through lush valleys where herds and predators crossed paths. Each niche was filled by a creature adapted to thrive in its conditions. Carnivorous theropods stalked silently through forests, while immense herbivores lumbered across open spaces, their massive feet pressing tracks into soft mud that would someday harden into fossils. Pterosaurs wheeled above, their wings catching thermals as they scanned for fish or carrion. Insects buzzed, mammals darted between roots, and the skies thundered with sound and life. These worlds were not alien, they were versions of our own, set to a different rhythm, pulsing under different stars, but obeying the same eternal rules of adaptation, hunger, and survival. Dinosaurs, in all their forms, were simply one chapter in that larger biological story, but what a grand chapter it was! Creatures that pushed evolution to its extremes, growing to unimaginable sizes, moving across continents, and developing behaviors that still echo in modern species. Among those echoes is the bond between parents and young, something long underestimated in prehistoric life. Fossil nests, eggs, and preserved brooding postures reveal that dinosaurs were attentive caregivers, building nests and colonies, defending their eggs, and feeding hatchlings. They lived lives not just of instinctual survival but of deep continuity, parents investing in future generations. Oviraptors, once maligned as thieves, became emblems of devotion, their fossils frozen in tender protection. Even massive species like Maiasaura, whose name means good mother lizard, show evidence of group nesting and care, suggesting that young dinosaurs remained in colonies long after hatching, learning and growing under the watch of adults. This sense of community paints a new portrait of their world, not a cold and mechanical chain of predators and prey, but a living network of social bonds, cooperation, and complexity. It invites us to imagine a dawn millions of years ago, a herd of hadrosaurs gathered on a riverbank, adults tending nests, hatchlings chirping softly, the air filled with low infrasonic calls used to keep families connected across the plains. Life in that ancient world was not primitive, it was profoundly alive, full of feeling, movement, and sound. Sound itself played a huge role in the lives of dinosaurs. Beyond the haunting calls of Parasaurolophus and the low rumbles of hadrosaurs, many species likely used sound as a crucial survival tool. Deep infrasound, vibrations too low for human ears, may have rolled across ancient valleys, carrying information from herd to herd. Like elephants or whales today, these tones could travel for miles, alerting others to danger or marking territory. The world of dinosaurs was not silent. It was filled with resonance, the drumming of feet, the bellow of predators, the rustle of foliage as giants moved through it, and a chorus of countless unseen creatures singing their presence to one another. Sound sculpted their existence as much as sight or smell, forming invisible threads of communication across vast landscapes. To stand in that world would have been to feel the earth itself vibrating with life. In that living world, evolution experimented boldly. Some dinosaurs, like Carnotaurus, were paradoxes of design, sleek and fast, yet with arms so small they seemed absurd. Evolution had rendered them nearly useless, frozen relics of anatomy that once served a purpose now lost. Yet Carnotaurus thrived, its streamlined body built for pursuit, its horned head a weapon of speed and precision. In contrast, the mighty Tyrannosaurus rex, often mocked for its small forelimbs, had arms that were compact but immensely powerful, capable of exerting forces strong enough to lift several hundred pounds. Perhaps they gripped struggling prey or aided in balance during mating. Evolution does not always sculpt perfection, it shapes functionality, adapting form to purpose, even if the result appears strange to us. The dinosaur's variety is proof that there was no single, right, way to survive, only ways that worked. Among the most fascinating revelations of modern paleontology is how fast many dinosaurs grew. Bone cross-sections reveal growth rings that tell stories of acceleration and slowdown, of juvenile energy burning through calories like wildfire. A sauropod hatchling could gain dozens of pounds a day, transforming from something the size of a puppy to the size of a horse in a year, and into a titanic giant within a decade. This explosive growth required not only vast amounts of food but also highly efficient metabolism, suggesting that many dinosaurs were warm-blooded. Their hearts must have pumped with vigor, their blood carrying oxygen to support such rapid expansion. The earth they lived on was warmer, oxygen levels higher, and vegetation abundant, a perfect cradle for giants. Dinosaurs also changed profoundly through their life cycles. Some species hatched with small, sharp teeth that later disappeared, reflecting shifts in diet and behavior as they matured. Young individuals may have eaten insects or soft vegetation before transitioning to tougher plant matter or meat as they grew. These transformations mirror the metamorphosis of modern animals, revealing that the journey from hatchling to adult was a process of continual adaptation. Each stage of life had its own challenges and solutions, shaped by both genetics and environment. Yet even as evolution crafted their individual destinies, it was also shaping entire lineages toward new possibilities. Feathers, once thought unique to birds, appeared in numerous dinosaur families. They served not only for insulation but also for display and, eventually, flight. In the forests and plains of the late Mesozoic, feathered dinosaurs would have shimmered with patterns and colors, the earliest echoes of what would one day become the diversity of modern birds. The boundary between dinosaur and bird grows thinner with every fossil found. We now understand that birds are not descendants of dinosaurs. They are dinosaurs, the last survivors of that ancient dynasty, carrying their heritage in every flap of a wing, every call that rings through morning air. When the Great Extinction came, it reshaped everything. The skies darkened, forests burned, and ecosystems collapsed. Yet, some small, feathered creatures endured, adapting to a new world where giants could no longer survive. Their resilience is a reminder that survival is not about strength alone, it's about flexibility, intelligence, and the ability to change. Dinosaurs ruled the Earth for over 160 million years, an achievement unmatched by any other group of land animals. They crossed continents, adapted to poles and deserts, and evolved into astonishing diversity. From the thunder-footed sauropods to the delicate microraptors that glided between trees, their reign was vast and beautiful. Today, When we look at the fossilized bones, skin impressions, or traces of pigment preserved in stone, we are not just seeing remnants of death, we are witnessing frozen moments of life. The imprint of a footstep, the curve of a crest, the delicate outline of a feather, each one is a whisper from a world long gone, yet strangely familiar. Dinosaurs were not monsters of imagination but living creatures, each heartbeat as real as ours once was. Their legacy surrounds us in every bird that sings, in every scaled reptile basking in sunlight, in every fossil that tells a story millions of years old. To study them is to listen to the echo of deep time, a reminder that Earth has been alive far longer and far more wondrously than we can easily comprehend. And though their age ended in fire and shadow, their story never truly died. It continues in the flutter of wings, the pulse of evolution, and the enduring wonder that still stirs whenever we say the word dinosaur. When scientists began uncovering the microscopic world preserved within fossils, they discovered something extraordinary: melanosomes, the pigment-carrying structures that once gave feathers their color, frozen in time for tens of millions of years. Under powerful electron microscopes, these tiny organelles, once thought lost forever, told stories in shape and form. Rod-shaped melanosomes hinted at blacks and grays, spherical ones at reddish browns, while more complex, layered types suggested shimmering iridescence, much like the feathers of hummingbirds or starlings today. What had once been imagined as a world of dull, mud-colored giants was revealed as a radiant kingdom alive with color and pattern. Picture a small raptor shimmering blue and green in the morning light, or another glowing copper red as the sun filters through ancient ferns. This realization shattered the drab image of dinosaurs and repainted the Mesozoic landscape into something alive, vibrant, and full of motion. Fossils once seen as lifeless bones suddenly carried echoes of the living world they once supported. Creatures adorned with feathers tipped in fiery orange, gleaming black, and dazzling metallic hues. One Chinese dinosaur, Anchiornis, for instance, revealed a black and white body crowned with rusty red feathers, a striking look more akin to a modern woodpecker than the scaly reptilian monsters long imagined. It was as if time itself had folded, offering us glimpses not just of skeletons, but of living beings that once filled the forests with flashes of color and movement. Imagine walking through that prehistoric world, sunlight filtering through broad, fern-like leaves, catching the glint of iridescent scales or feathers as small dinosaurs dart through the undergrowth. Their colors weren't merely decoration, they were tools, languages, and survival mechanisms in a world that pulsed with competition and life. Some species mastered camouflage, their feathers banded or speckled to mimic the shifting shadows of forest floors or grasslands, vanishing from predators just as modern birds and tigers blend into their surroundings. These patterns weren't random, they were the results of evolution's artistry, sculpted through countless generations to hide, signal, or deceive. Imagine a tiny predator crouched in the leaf litter, invisible until it bursts forward in a sudden flash to catch its prey, or a massive herbivore whose mottled hide breaks up its outline beneath the dappled sunlight of the forest canopy. In this ancient theater, color was not a luxury, it was survival itself. Yet camouflage was only one side of the spectrum. Other dinosaurs wore their colors boldly, flaunting vivid patterns to intimidate rivals or entice mates. Just as a peacock's tail spreads in dazzling defiance, some dinosaurs may have displayed brilliant stripes, frills, or crests that turned them into living spectacles. Fossil evidence of display structures, frills, crests, horns, suggests that many species were not shy about showing off. A ceratopsian might have reared up, its great frill flashing in radiant hues of blue or yellow to warn off competitors or to court a mate. A raptor might have spread its feathered limbs in a sudden display, the undersides marked with bright patterns designed to startle or impress. The fossil record, while fragmentary, whispers of a prehistoric pageant where color was a signal, a message, and a weapon all at once. Take the ceratopsians, for example, the horned dinosaurs like Triceratops and Styracosaurus, whose skulls bore vast, ornamented frills that stretched like living banners. While these frills may have offered some protection, their delicate edges and elaborate shapes suggest another purpose entirely: communication. Each species had its own design: scalloped rims, ornate spikes, even open spaces that formed intricate patterns. Picture herds of these creatures moving across open plains, sunlight catching the curves of their frills as they tilt their heads, signaling strength, maturity, or identity. In a world without words, these bony canvases were language made visible, like the antlers of deer or the manes of lions today. The frill became more than defense. It was an emblem of status and survival, a prehistoric billboard glowing with life's coded meanings. And then there were the pachycephalosaurs, the dome-headed dinosaurs whose skulls could reach over 10 centimeters thick, denser than a baseball bat, built like living battering rams. For years, scientists debated their purpose. Were they for protection from predators, or were they instruments of combat within their own kind? Evidence of healed fractures and bone remodeling tipped the scales toward the latter. These animals likely engaged in fierce contests, charging headlong into one another with bone-rattling collisions that echoed through the forests. Imagine two pachycephalosaurs circling in a dusty clearing, muscles tense, heads lowered, before slamming together with a resounding crack that sent shockwaves through the ground. The force must have been immense, but the thick domes absorbed the impact, protecting the brain beneath. Scars on fossil skulls tell of these repeated clashes, ritual battles for dominance, territory, or mates. Not every contest may have been violent, though. Some might have been decided through posturing and tilting displays, much like modern rams or deer assess one another before locking horns. These fossils tell a story of a society structured not only by brute strength but by complex behaviors, rituals, and signals, a reflection of the same evolutionary logic that drives life today. Yet even in battle, dinosaurs displayed remarkable resilience. Many species, especially the horned ones, show evidence that their horns could heal and even regrow after damage. Fossilized skulls reveal fractures that later refused, suggesting the regeneration of tissue and bone. In a world where horns were both weapons and displays, this was no small advantage. Imagine two triceratops locking horns in a thunderous duel. One horn splinters, leaving a gaping wound, yet over time, the dinosaur's body rebuilds it, an evolutionary triumph of recovery and persistence. These creatures weren't only powerful, they were durable, capable of repairing the very tools they fought with. Resilience was woven into their design, ensuring that even after the fiercest battles, life would find a way to mend and continue. Among the most iconic of all dinosaurs were the raptors, sleek, intelligent predators that carried a weapon both elegant and deadly, the sickle claw. Curved like a scythe and kept razor-sharp by being held off the ground, it was a masterpiece of evolutionary engineering. In a leap, a raptor could pin its prey with its forelimbs while driving that curved claw downward in a slashing motion of terrifying precision. Every motion was calculated, an explosion of speed, coordination, and lethality. This single claw, just a few inches long, symbolized the apex of predatory design. Its curve, sharpness, and the way it was positioned for attack tell us about how these animals hunted, not through brute force, but through agility, teamwork, and precision. The more we learn about these creatures, the more we realize how complex their world truly was. It was not merely a planet of roaring beasts locked in endless combat, but a dynamic ecosystem where beauty, adaptation, and intelligence coexisted with brutality and survival. The colors that flashed through the forests were not accidents. They were part of nature's language, written in pigment, pattern, and form. Every scale, feather, horn, and claw carried meaning, a message of strength, warning, or desire. Even after millions of years, the fossils that survive still hum with the echoes of those meanings, allowing us to reconstruct not just what dinosaurs looked like, but how they lived, fought, and displayed themselves in a world that was far more intricate and vibrant than we ever imagined. The earth beneath their feet was alive with their stories of light, color, rivalry, and resilience, preserved in stone and rediscovered piece by piece. And so, through the smallest details, through the shape of a melanosome, the scar on a dome-shaped skull, or the curve of a sickle claw, we glimpsed not just bones, but the beating heart of a world long gone, painted once more in the full spectrum of life. The relationship between dinosaurs and their world was a breathtaking balance between form and function, every feature shaped by evolution's patient hand into something purposeful, elegant, and efficient. Among the most remarkable examples of evolutionary weaponry were the curved sickle claws of raptors, sleek, razor-sharp instruments of death that made these relatively small dinosaurs some of the most dangerous predators of their ecosystems. These claws were masterpieces of natural engineering, each one crescent-shaped, honed to perfection, and sharper than a steak knife. Fossilized raptor claws, when examined under microscopes, reveal microscopic grooves and wear patterns that speak of repeated slicing motions, like blades sharpened through relentless use. Picture a creature armed not with metal or fire but with living blades strapped to its feet, tools of predation so efficient that even humanity's finest weapons pale in comparison. Raptors could leap high, kick with deadly accuracy, and use their claws to slash open flesh or pin down prey, gripping their victims as their jaws delivered the fatal bite. They were not merely animals but finely tuned machines of survival, embodying the precision and intelligence that evolution could produce. Small in size but colossal in lethality, they remind us that dominance in nature is not always measured in mass or strength but in the refinement of design. And while raptors hunted with speed and cunning across the ancient southern continents, another predator claimed the title of giant, Giganotosaurus, the colossal hunter of Cretaceous Patagonia. For decades, Tyrannosaurus rex reigned as the largest carnivorous dinosaur known to science, but discoveries in South America revealed a rival that challenged its supremacy. Stretching over 40 feet in length and with a skull more than 5 feet long, Giganotosaurus was a terrifying force of nature, larger in many measurements than T. rex. But while T. rex crushed bone with its powerful jaws, Giganotosaurus relied on slicing. Its teeth, long and serrated like rows of butcher's knives, were designed not to pulverize but to cut, to tear great ribbons of flesh from its prey. One can imagine it stalking the open plains of prehistoric Argentina, its massive silhouette gliding across the horizon, jaws lined with blade-like teeth glinting under the sun. It likely hunted Argentinosaurus, the colossal herbivore that towered over all land life. The two creatures represented opposing extremes of evolution, predator and prey, each immense, each adapted to an unforgiving world. The existence of Giganotosaurus proved that evolution did not craft its giants once, but many times, across continents, sculpting apex predators wherever opportunity demanded. Yet even Giganotosaurus would have bowed in size to its herbivorous neighbor, Argentinosaurus, the mightiest of all land dwellers. Estimated to reach up to 100 feet in length and weighing over 70 tons, this titanosaur was a moving mountain of life, its body so vast that a single vertebra outweighed a grown human. To imagine such a creature alive is to picture a living bridge stretching across the prehistoric landscape, its long neck sweeping through the treetops as it stripped branches clean, while its immense tail swayed like a pendulum behind it. The ground must have quaked with every step, and the air itself would have seemed to tremble in its presence. Despite their size, these titans were gentle giants, likely moving in herds across vast plains, consuming forests of vegetation to sustain their immense bodies. Evolution had pushed the limits of what was physically possible, turning flesh and bone into a symphony of size and balance. And yet, while creatures like Argentinosaurus reached such incredible dimensions, others explored the opposite end of the spectrum. Among the tiniest of all known dinosaurs were the delicate, bird-like Microraptor and its minuscule relatives, creatures so small that some weighed less than a modern mouse. Barely longer than a human hand, these feathered dinosaurs darted through the undergrowth and treetops, living fast and dying young in a world ruled by giants. With lightweight bones, sharp claws, and keen eyes, they hunted insects, nibbled on fruit, and perhaps glided from branch to branch under the cover of leaves. Imagine crouching in the prehistoric twilight and seeing a flicker of motion, a blur of iridescent feathers, a rustle of leaves, and then nothing. These tiny dinosaurs, almost invisible against the vastness of their world, remind us that survival takes many forms, and sometimes the greatest strength lies in speed, agility, and obscurity rather than might. While the dinosaurs roamed above, another lineage of life shared their world, small mammals, the quiet survivors of the Mesozoic. Often no larger than modern rats or shrews, these mammals scurried under ferns, dug burrows, and emerged under the cover of night to forage for insects, seeds, and carrion. For over 100 million years, they lived in the shadows of reptilian giants, adapting with cunning where they lacked size. Their existence was a miracle of endurance. They evolved soft fur for warmth, keen senses for night living, and complex teeth for varied diets. Some were egg layers like modern monotremes, others gave live birth. Some glided between trees, while others tunneled underground. Their smallness was their armor, a way to avoid the gaze of predators and to persist through ages of dominance they could never hope to challenge. Picture a Mesozoic night. The deep roars of dinosaurs echo in the distance while, in the shadows beneath cycads and towering conifers, small furry creatures scurry silently, their eyes glowing faintly in the moonlight. Theirs was a hidden world, running parallel to the Age of Giants, a quiet prelude to the age of mammals that would one day come. But even these small creatures were not always meek. Fossils reveal that some early mammals hunted baby dinosaurs. Tiny jaws preserved in stone contained the bones of hatchlings, proof that in this ancient world, even the mightiest were vulnerable at birth. Imagine a scene where a mammal, no bigger than a cat, creeps toward a nest filled with chirping baby dinosaurs. In a flash, it strikes, sharp teeth tearing through fragile bodies, before vanishing back into its burrow as a distant roar shakes the air. It's a sobering reminder that nature's balance is never one-sided. Even the rulers of an era must guard their young against unexpected dangers. While life and death played out in these endless cycles, the landscape itself was changing. During the Cretaceous period, a quiet revolution began, one that would transform not only the Earth's surface but the very way life reproduced. This was the rise of flowering plants, the angiosperms. Before their appearance, the world had been dominated by ferns, cycads, and towering conifers, green, spiny, and ancient. Then, seemingly suddenly, came color and scent. Flowers began to bloom across the continents, painting the prehistoric world with hues that had never existed before. Their arrival brought new ecological relationships, as plants evolved to attract animals for pollination and seed dispersal. Dinosaurs walked through the first meadows and forests of blossoms, their feet crushing petals that shimmered with early pigments. Herbivores that once fed on ferns began nibbling on leaves and flowers, tasting the beginnings of the diets that would one day sustain mammals. Imagine a hadrosaur lifting its head among cycads to pluck a cluster of newly bloomed petals, its movement scattering pollen into the warm air. These early interactions between dinosaurs and flowers shaped ecosystems that laid the foundation for the world we know today. By the end of the Cretaceous, flowering plants had spread across nearly every environment, from wetlands to plains, outcompeting the ancient flora that had ruled for millions of years. The planet had changed from monotone green to a vibrant tapestry of blooms, fruits, and scents. Insects adapted alongside them, learning to collect nectar, while small feathered dinosaurs and primitive birds likely played their part too, brushing against petals, carrying pollen from one blossom to another. Life had become interwoven in new ways, mutual, delicate, and complex. The Earth was no longer just a stage for reptilian power but a living garden in transition, unknowingly preparing for a future where mammals, and eventually humans, would flourish. To imagine this world in full color is to see dinosaurs not as static bones in a museum but as creatures of light and movement, predators with gleaming claws sharper than steel, gentle titans grazing among the first flowers, and tiny feathered hunters darting through scented air. They lived in a time when the Earth was experimenting with form, where evolution tested every boundary, from the smallest mammal that hunted under moonlight to the largest herbivore that could blot out the sun. Together, they formed a symphony of survival, a reminder that life, in every era, is both fragile and unstoppable. The dinosaurs may have fallen, but the beauty of their world, the color of their feathers, the strength of their bones, the seeds they carried on their skin, echoes in every living thing that came after them, including us. Between form and function, nature has always sculpted perfection through purpose, and nowhere is that more evident than in the claws, teeth, and towering forms of the dinosaurs that once ruled our planet. Crafted by evolution for maximum impact, the curved talons of raptors stand as masterpieces of biological engineering, sleek, efficient, and deadly. They were sharper than modern steak knives, their fossilized remains still showing grooves and wear patterns that reveal lifetimes of cutting and slashing, each motion honed through constant use like the blade of a master craftsman. Imagine encountering a creature armed with knives strapped to its feet, capable of leaping, kicking, and striking with surgical precision. That was the raptor, small yet formidable, intelligent yet ruthless, using its claws not only to kill but also to pin and grip its prey while its jaws delivered the final, fatal bite. These claws, natural blades sharper than steel, remind us that evolution can be as inventive and efficient as any human blacksmith. Yet beyond the raptor's razor-edged artistry were the true giants, predators so vast they stretched the imagination, creatures like the Giganotosaurus, the colossal rival to the legendary Tyrannosaurus rex. Once believed to be the ultimate carnivore, T. rex lost its exclusive crown when fossils unearthed in South America revealed Giganotosaurus, a predator longer than a bus, its skull alone over 5 feet long. Unlike T. rex's bone-crushing bite, Giganotosaurus wielded serrated teeth built to slice through flesh in great ribbons, using speed and precision to bring down massive herbivores like Argentinosaurus. Picture it stalking the ancient plains of Patagonia, jaws lined with blade-like teeth gleaming in the sun, a living engine of hunger and power. Its discovery proved that nature's creativity in crafting apex predators was not limited to one lineage or one continent. Giants arose again and again, each uniquely adapted for dominance. And yet, even among such monsters, Argentinosaurus stood apart, perhaps the largest land animal ever to walk the earth. Stretching nearly 100 feet in length and weighing over 70 tons, it was a living mountain, its neck arching high into the treetops, its footsteps shaking the ground beneath. Herds of these titans must have looked like moving hills crossing the plains, their tails swaying like living bridges, their immense bodies covered in scales that shimmered in prehistoric sunlight. Despite their size, they were gentle grazers, their lives ruled by rhythm and motion, eat, move, survive, an echo of the cycles that still govern life today. But not all dinosaurs were giants. At the other extreme of evolution's canvas were the tiny wonders like Microraptor, no larger than a modern mouse, delicate, feathered, and impossibly quick. These small predators darted among branches, chasing insects and hiding from the giants that thundered above. Imagine crouching in a fern-filled forest and seeing a flicker of movement, a flash of feathers, a tiny eye gleaming in the dappled light. Proof that not every success story in evolution is written in size or strength. For every towering sauropod, there was a sparrow-sized survivor, showing that nature values adaptability as much as power. These small dinosaurs competed not only with each other but with the earliest mammals that shared their world. In the shadows of the Mesozoic, while the earth shook under the weight of dinosaurs, small mammals scurried quietly at their feet. They were nocturnal survivors, eating insects, nesting underground, and avoiding notice. Fossils reveal that they thrived alongside dinosaurs for over 100 million years, evolving into gliders, burrowers, and live-bearers, quietly preparing for their eventual rise after the Great Extinction. Imagine a Mesozoic night, the air alive with the rumble of massive feet above while tiny, fur-covered creatures crept silently below, listening, waiting, enduring. In this ancient balance between giants and survivors, some mammals even turned predator, bold enough to raid nests and devour baby dinosaurs. Fossils reveal their teeth marks on fragile bones, reminders that no creature, no matter how powerful, is entirely safe. It is humbling to think that a creature no bigger than a house cat once hunted the young of dinosaurs that dwarfed elephants. Such moments show that nature's drama has always been one of balance, between strength and cunning, might and opportunity. As the Mesozoic unfolded, another quiet revolution took root, the rise of flowers. Before their arrival, the world was dominated by ferns, cycads, and towering conifers. But during the mid-Cretaceous, flowering plants, angiosperms, began to bloom, painting the prehistoric world with color and scent. Their petals unfurled beneath the feet of dinosaurs, their nectar attracting the first pollinators. Dinosaurs roamed through the earliest gardens the Earth had ever known. Herbivorous species began feeding on these new plants, and in turn, they spread their seeds and pollen, forging unseen partnerships. Imagine a hadrosaur pausing between cycads to nibble on a strange, fragrant blossom, unknowingly helping the plant propagate its kind. By the end of the Cretaceous, flowers had conquered the continents, filling forests and meadows with brilliant hues and changing the very structure of ecosystems. This floral revolution reshaped not just the plant kingdom but also the diets and behaviors of dinosaurs. Small feathered species, some no larger than pigeons, may have carried pollen between blooms just as modern birds do today. Picture a tiny feathered dinosaur flitting from flower to flower, sipping sweet nectar, unknowingly becoming one of the first pollinators, a hummingbird's ancestor in spirit if not in form. Evolution, after all, thrives not only on competition but on cooperation, on the quiet exchange between species that sustains worlds. But not all changes were beautiful. The vast herds of sauropods that roamed the Earth likely affected the planet's climate in surprising ways. Scientists now believe that the methane produced during their digestion, much like modern cattle, may have been enough to warm the atmosphere by several degrees. It's almost comical to imagine, yet it highlights how profoundly life can shape its own environment. The breath, waste, and even digestion of ancient creatures contributed to the chemistry of the air itself. In this way, dinosaurs remind us that climate has never been purely geological. It has always been biological too, sculpted by the lives that inhabit it. Those same sauropods also played the role of gardeners. Fossilized dung, known as coprolites, reveals seeds preserved inside, proof that the plants they ate were later scattered across miles of land in their droppings. Each pile of waste carried the beginnings of new forests, turning digestion into distribution. Imagine a vast sauropod herd lumbering across the plains, leaving behind not just footprints but future ecosystems in their wake. Evolution, in its subtle brilliance, turned even waste into opportunity. And from those ancient droppings, paleontologists now glean stories written in stone. Fossilized dung may not sound glamorous, but within it lie seeds, bone fragments, and shells that reveal what dinosaurs ate and how their ecosystems functioned. One enormous specimen, weighing over 40 pounds, likely came from A.T. Rex, packed with splintered bone from its prey, a prehistoric record of digestion frozen in time. Through coprolites, scientists reconstruct food webs, plant diversity, and even digestion rates. They turn what was once waste into data, a reminder that no trace of life is too humble to matter. And sometimes these fossils show more than droppings. They preserve the contents of dinosaur stomachs themselves. Inside ribcages, paleontologists have found fish bones, plant matter, and even other dinosaurs, preserved mid-digestion. These rare finds let us see not just what dinosaurs could eat, but what they actually did. Imagine a microraptor frozen in stone, its last meal, a small bird, still inside, a snapshot of life and death caught forever. To aid in their feeding, some dinosaurs even swallowed stones, known as gastroliths, which tumbled inside their stomachs, grinding food in the absence of chewing teeth. These smooth, polished stones, found nestled within rib cages, tell stories of clever adaptation. Without them, giant herbivores might not have been able to process the vast amounts of fibrous plant material they consumed daily. Over time, the stones grew round and glassy from use, proof of the slow, mechanical dance of digestion that turned leaves into life. Modern birds still use gastroliths today, a direct evolutionary thread connecting sparrows to sauropods. Imagine one of those massive creatures pausing by a river, swallowing a few pebbles to help it digest an afternoon's worth of treetop leaves, simple, practical, and profoundly ancient. These stones, small as they are, remind us that evolution's inventions often persist across eons, unchanged because they work so perfectly. And towering above all others were the sauropods' necks, engineering marvels that stretched longer than a giraffe's entire body. Some measured over 30 feet, yet were light and strong thanks to air-filled bones and powerful muscles. These necks allowed sauropods to graze across vast areas without moving their massive bodies, sweeping high branches or ground-level plants with ease. The physiological challenge of pumping blood to a brain so high above the heart is still a puzzle scientists study today, yet nature solved it millions of years ago. Imagine standing in a prehistoric forest, craning your head back as a sauropod's head moves like a crane above the treetops, its every motion deliberate, slow, and majestic. These creatures redefined the boundaries of what life could build. Evolution, with time and necessity as its tools, crafted beings that were both delicate and immense, terrifying and beautiful. From the tiniest feathered hunter to the largest leaf-eating titan, dinosaurs filled every niche, their existence a symphony of form and purpose. They lived, breathed, ate, and died, leaving behind a world shaped forever by their presence. Their bones and even their waste became the letters in Earth's oldest story, one still being read, piece by piece, from the stones beneath our feet. Sauropods were among evolution's most extraordinary creations, stretching the limits of biology and physics to become living skyscrapers that redefined what it meant to be large on land. Some of these colossal creatures possessed necks that seemed to reach for the heavens, supported by more than 15 vertebrae, each one a marvel of natural engineering. Humans, by contrast, have only 7 neck vertebrae, yet the sauropods evolved to multiply and elongate them into intricate, lightweight structures filled with air sacs that reduced weight without sacrificing strength. Their bones were masterpieces of design, honeycombed with hollows and ridges for muscle attachment, and arranged in ways that allowed both stability and sweeping flexibility. Picture a diplodocus, its neck stretching across the breadth of a city street, each vertebra contributing to a magnificent chain that turned its body into one of nature's greatest experiments in size and function. The ingenuity of this anatomy showed how repetition and adaptation of simple biological units could build structures beyond imagination. Among these titans, titanosaurs stood out not only for their sheer size but also for their armor. Their skin was studded with bony plates, osteoderms, embedded like shields beneath the surface. These varied in size from tiny nodules to plates several inches across, forming a mosaic of natural armor that may have deterred predators or perhaps shimmered under the sun as a display feature. Imagine a creature longer than a basketball court, its hide glinting faintly as it lumbered across ancient plains, a fusion of beauty and defense. These osteoderms connected titanosaurs to other armored reptiles such as crocodiles and ankylosaurs, revealing that evolution often revisited the idea of bony skin as a defensive innovation. For titanosaurs, this armor added yet another layer of resilience to bodies already pushing the boundaries of what nature could sustain, transforming them into living fortresses of flesh, bone, and stone. Not all sauropods carried their necks in the same majestic pose. Some, like Diplodocus, kept their necks extended outward, horizontal to the ground, sweeping from side to side like a colossal vacuum hose. This posture allowed them to graze vast areas of vegetation without moving their massive bodies, a remarkable energy-saving strategy. Picture such a giant standing still in a Jurassic meadow, its neck gently swaying in graceful arcs as it plucked ferns and cycads, clearing a wide path through the forest without a single step. Others, such as Brachiosaurus, held their necks upright like living cranes, towering above the treetops to browse on leaves no other creature could reach. The contrast between these two feeding strategies, horizontal grazers and vertical browsers, reveals how evolution diversified even among giants, allowing multiple species to coexist without competing for the same food. Their necks were not just long, they were precision instruments shaped by millions of years of adaptation, each curve and vertebra fine-tuned for balance, motion, and survival. The contrast between these two feeding strategies, horizontal grazers and vertical browsers, reveals how evolution diversified even among giants, allowing multiple species to coexist without competing for the same food. Their necks were not just long, they were precision instruments shaped by millions of years of adaptation, each curve and vertebra fine-tuned for balance, motion, and survival. The Brachiosaurus, perhaps the most iconic of them all, stood as tall as a 5-story building, its body sloping upward with longer front legs than hind legs, giving it a posture unique among dinosaurs. This upward tilt made it look like a living construction crane, capable of reaching the highest branches of Jurassic forests. Imagine walking through that world, ferns brushing your knees, dragonflies the size of hawks drifting through shafts of golden sunlight, and looking up to see a Brachiosaurus, its head lost among the treetops, calmly chewing on leaves that no other creature could reach. Its heart, one of the most powerful ever evolved, pumped with enough force to send blood coursing up that immense neck to its brain, sustaining life in a structure that seemed to defy gravity. Standing beside such a creature would have been like standing at the base of a moving building, an awe-inspiring monument of muscle and bone that dwarfed everything in its path. Even small details of its anatomy carried fascinating mysteries. For instance, its nostrils were positioned unusually high on its skull, near the top of its head. Early scientists once imagined these high nostrils allowed the animal to wade through rivers like a giant hippo, using them as snorkels, but modern research has reshaped that view. Instead, the placement may have helped with breathing while feeding high among branches or perhaps even contributed to communication, turning the skull into a resonating chamber for deep, rumbling calls that carry for miles. Some paleontologists speculate that the raised nostrils might have been used for display or social signaling. Imagine a brachiosaurus lifting its head, its nostrils flaring as it released a low, resonant sound that rippled through the forest canopy. In such moments, these gentle titans must have transformed the primeval world into a symphony of deep, trembling notes that only other giants could truly appreciate. Moving from the herbivores to the predators, the Jurassic world was equally rich in ferocity and beauty. Dilophosaurus, one of the earliest large predators of the Jurassic period, was distinguished by the twin crests rising elegantly from its skull, thin, delicate structures that were far too fragile for combat. Instead, they likely served as display features, bright and colorful beacons for attracting mates or intimidating rivals. Imagine its silhouette at dawn, a 20-foot-long predator with twin crests glowing in the morning light as it released a call across the ancient landscape. Despite popular portrayals in movies, the real Dilophosaurus did not spit venom or have a frill around its neck. That dramatic depiction, immortalized in Jurassic Park, was pure fiction designed for thrill and spectacle. In reality, this predator needed no such embellishment. With its sleek build, powerful legs, and striking twin crests, it was already a perfect blend of elegance and danger, a living testament to evolution's artistry. Science, through careful study of fossils, has restored the true majesty of this misunderstood creature, showing us that reality often surpasses imagination in wonder. The same is true for Velociraptor, perhaps the most famous dinosaur in modern culture, though almost everything people think they know about it comes from Hollywood rather than science. The movie version depicted them as man-sized, scaly, and terrifyingly sleek, but the real Velociraptor was much smaller, about the size of a turkey, and covered in feathers. Fossils from Mongolia have revealed quill knobs on their arm bones, the very spots where feathers anchor in modern birds. These feathers were not for flight but likely served for insulation, balance, and display, hinting at their bird-like agility. Picture a pack of feathered raptors darting through the underbrush, their movements quick and precise, feathers rippling as they chase down prey with deadly coordination. The revelation that these predators were feathered does not make them any less fearsome. If anything, it connects them more intimately to the world we know, reminding us that birds are their living descendants. They were not scaly reptiles but dynamic, warm-blooded hunters with intelligence, speed, and striking beauty, bridging the ancient past with the skies above us today. And then there was the mighty Tyrannosaurus Rex, the so-called king of the dinosaurs, whose image has roared through popular imagination for decades. Yet even its legendary roar is a product of fiction. Fossils cannot directly reveal sound, but comparisons with modern relatives, birds and crocodiles, suggest that T. Rex likely did not roar like a lion. Instead, it may have produced deep, resonant rumbles or infrasound vibrations that traveled through the ground and the air, sounds so low that humans might only feel them rather than hear them. Imagine standing on a Cretaceous plain as the ground subtly trembles and the air vibrates around you, a low, chest-rattling hum announcing the presence of an apex predator long before it appears. This kind of communication, silent, powerful, and primal, would have carried across great distances, signaling territory, dominance, or the hunt. The truth, once again, is more haunting than fiction. A T. Rex that could speak in the language of the earth itself, resonating through the landscape like thunder. When we piece together these glimpses from bone, sediment, and science, a vivid picture of prehistory emerges. Sauropods bending their necks like cranes and hoses to graze across the ancient world, titanosaurs shimmering in their bony armor, predators like Dilophosaurus displaying flamboyant crests and ritual displays, and feathered raptors sprinting through ferns beneath the gaze of towering giants, all of them parts of an intricate web of life that dominated the planet for over 150 million years. Each adaptation, be it the hollow vertebrae of a sauropod, the air sacs that lightened its frame, the armor that protected a titanosaur, or the feathers that cloaked a raptor, was a masterpiece of evolutionary design. Together, they formed a living world of astonishing scale and diversity, a theater of life where biology stretched itself to its limits and beyond. Even now, as we study their fossils, the bones of these creatures whisper stories of motion and survival, of ecosystems rich with color, sound, and movement. They remind us that the history of life on Earth is not just written in rock, but also in imagination, where giants walk again in our minds, breathing, moving, and calling across the eons. The deep, rumbling call of a Tyrannosaurus Rex would not have been a thunderous roar like the movies portray, but something far more primal and haunting, a low, resonant vibration that could be felt as much as heard, traveling through the earth and air, warning every living creature that the king of predators was near. These infrasound waves, too deep for human ears, would have made the Cretaceous landscape tremble with anticipation and fear, a soundscape of life that has long since vanished. Though fossils cannot speak, their silence still whispers hints of such moments, of voices so strange and powerful that even the imagination struggles to grasp them. Yet sound is not the only trace these ancient beings left behind. Across the globe, vast footprints pressed into mud and sand have endured the march of time, petrified into stone as if the earth itself refused to forget the weight of these giants. Some dinosaur tracks stretch more than 3 feet wide, larger than a human chest, each one a perfect impression of unimaginable mass. Standing in one today feels like stepping into the shadow of a ghost, where an animal weighing tens of tons once placed its foot. The largest of these tracks often belong to sauropods, whose immense, circular footprints reflect feet designed to spread their colossal weight evenly. Others, carved with sharp claw marks, reveal the power of giant theropods, predators whose every stride pressed authority into the soil. These fossilized tracks reveal details that bones alone cannot. They show how the creatures moved, how fast they walked or ran, even how their toes curled into the soft earth as they lifted their weight with each step. Some tracks are clustered into long trails, telling stories of movement through ancient landscapes, a herd migrating, a predator stalking, a mother walking beside her young. Each preserved footprint bridges millions of years, turning stone into story. Fossilized trackways go beyond static evidence. They are snapshots of behavior frozen in time. Some show dinosaurs sprinting, their footprints spaced far apart, proving that even the largest beasts could run with surprising speed. Others capture moments of stillness, where a dinosaur crouched to rest, leaving the imprint of its belly, tail, and even forearms pressed into the mud. There are marks that suggest slipping and sliding, perhaps from an animal losing balance on a wet slope or even playing in a muddy riverbank. Imagine a Cretaceous floodplain where a young dinosaur skids in the mud, its claws scraping the ground, unaware that this fleeting moment of movement will one day be studied by scientists eons later. These dynamic fossils transform our understanding of dinosaurs from static skeletons into living, breathing beings, creatures that rested, stumbled, ran, and played just as animals do today. Some of the most touching trackways show large footprints side by side with smaller ones, suggesting mothers walking alongside their young. The tiny prints keep close to the larger ones, moving in synchrony, revealing bonds of care and protection that stretch across prehistory. In some trackways, scientists see evidence of coordinated group behavior, adults forming a loose ring around juveniles, as if guarding them from danger. Visualize a Cretaceous plain at sunset, where a mother dinosaur leads her hatchlings across a muddy field, each step pressed deep into the earth that will one day harden into stone. Millions of years later, those fossilized steps still speak of family and tenderness, of life that cared and protected as fiercely as it survived. These imprints remind us that even in the age of giants, love and connection left marks as enduring as bone. Sometimes, science begins not with a laboratory or a university grant, but with someone simply noticing something strange beneath their feet. Long before paleontology existed, people were already finding these relics and trying to explain them with the knowledge they had. In 17th century England, when massive femur bones were unearthed, they were often thought to belong to biblical giants or ancient heroes from myth. Without the concept of extinct species, people interpreted what they found through stories of gods, monsters, and legends. Enormous teeth were attributed to dragons or elephants, and skull fragments were mistaken for those of ancient warriors. It was not until the 19th century, when scientists like Richard Owen recognized that these bones belonged to a completely different kind of creature, ancient reptiles far older than humanity, that the word dinosaur was born. This revelation reshaped our understanding of Earth's history, proving that humanity was but a brief chapter in a far older book. Yet those early myths remain a fascinating window into how people once made sense of the deep past. Before they were dinosaurs, they were giants, heroes, or gods in human imagination. The connection between dinosaurs and dragons runs deeper still. Across cultures, from China to Europe to the Americas, stories of dragons have existed for thousands of years. Many scholars believe these myths were inspired, at least in part, by discoveries of dinosaur fossils. In ancient China, large fossilized bones were often ground into powder for traditional medicine and sold as dragon bones, believed to hold mystical power. In medieval Europe, farmers and travelers who unearthed enormous femurs or skulls with sharp teeth often imagined they had found the remains of slain dragons. Picture a villager centuries ago, holding a fossilized bone the size of his arm, unable to explain its origin. To him, it was not a relic of science but a relic of legend, a reminder that monsters once walked the earth. And in a way, he was right. Those dragons did exist. Only not as fire-breathing serpents, but as real creatures of flesh and blood that once dominated the planet. In this sense, dinosaurs never truly disappeared. They lived on in stories, transformed by imagination into the dragons of folklore and myth. The 19th century brought both scientific progress and fierce rivalry. During the so-called Bone Wars, two ambitious paleontologists, Othniel Charles Marsh and Edward Drinker Cope, competed ruthlessly to discover and name the most dinosaurs. Their rivalry drove an unprecedented rush of fossil hunting across North America, leading to the discovery of over 100 new species, including iconic giants like Triceratops, Stegosaurus, and Allosaurus. But the competition also descended into sabotage and scandal. They bribed field workers, destroyed each other's fossils, and rushed publications to claim credit. Despite the chaos, their feud transformed paleontology forever, igniting public fascination with dinosaurs and laying the foundation for modern scientific study. What began as a bitter contest ultimately gave birth to an entire field of wonder. And so, from the first misunderstood bones mistaken for dragon relics to the fierce rivalries of 19th century scientists, and the modern-day discoveries of new species, the story of dinosaurs continues to evolve. The Earth itself remains an open book, its pages written in stone, its words carved by the feet and bones of creatures that ruled the world long before us. Every fossil is a whisper from a vanished age, a fragment of a song that once echoed across primeval forests and ancient seas. The dinosaur's legacy is not confined to museums or textbooks. It is alive in the myths we tell, the questions we ask, and the awe we feel when we imagine a time when giants walked the earth. From the thunder of their steps to the tremor of their voices, from footprints turned to stone to feathers preserved in amber, their world still speaks, and as long as we keep listening, their story will never end. The rivalry between Edward Drinker Cope and Othniel Charles Marsh, known as the Bone Wars, stands as one of the most extraordinary and chaotic episodes in the history of science, driven by ego, ambition, and the hunger to unearth the ancient giants of Earth. These two men, once colleagues and later fierce enemies, dedicated their lives to outdoing one another in the race to discover and name more dinosaur species than the other. Their competition turned the fossil-rich landscapes of the American West into battlegrounds of discovery and sabotage. Expeditions were dispatched at breakneck speed, workers dug feverishly, and entire fossil sites were occasionally destroyed simply to keep them from falling into rival hands. The pace of discovery during this period was nothing short of astonishing. Between the 1870s and 1890s, more than 100 new species were identified, including icons like Stegosaurus, Triceratops, Diplodocus, and Allosaurus, names that still inspire wonder today. Yet this progress came at a cost. The rush led to errors, incomplete reconstructions, and misidentified fossils. Some skeletons were hastily assembled, with bones placed in the wrong positions, and species were sometimes named twice under different labels. Despite these flaws, the Bone Wars ignited worldwide fascination with dinosaurs and transformed paleontology from an obscure pursuit into a major scientific discipline. Museums filled with towering skeletons, and for the first time, humanity could walk beneath the colossal frames of creatures that once ruled the earth. Visitors who gazed up at these reconstructed giants in the late 19th century must have felt a mixture of awe and disbelief, as if they were glimpsing a world both alien and familiar. For all the chaos, the rivalry between Cope and Marsh accelerated discovery on an unprecedented scale, revealing North America as one of the richest sources of prehistoric life on the planet. However, the same intensity that fueled discovery also fostered deception. In their desperation to outdo each other, both men sometimes made hasty conclusions. Cope famously reconstructed a marine reptile with its head placed on the wrong end of its body, a mistake that humiliated him publicly. Marsh too published species based on fragmentary remains, leading to confusion that later generations of paleontologists would need to untangle. Some dinosaurs named during that period turned out to be duplicates, variations of the same species identified separately in the rush to claim credit. These scientific missteps became part of the drama, showing how human flaws, pride, rivalry, ambition, could both advance and distort knowledge. Yet through these missteps, science evolved, refined, and grew. Later researchers painstakingly corrected the record, revising classifications and reassembling skeletons accurately. What remained undeniable was the impact of the Bone Wars, an explosion of discovery that reshaped our understanding of life's deep history. Out of rivalry and case, modern paleontology was born.